Nowadays, applications of mathematics to real-world scenarios are being made almost everywhere. For example, running a business efficiently requires us to maximize profit and measure the rate of increase in profit relative to the quantity produced to effectively make money. We can also calculate temperature variation to find out which days are hottest and coldest. Estimate when the next occurrence of an earthquake will be, and find the velocity and acceleration of an object. All these examples require derivatives.
For this video, we'll use derivatives to find the velocity and acceleration of an object, as it is the most applicable scenario. This is because with only a position function given, we are able to find the velocity and accelerations since they all measure the rates of change of each other. So what exactly is derivative? A derivative is a function that shows us the rate of change of a variable relative to another. It may also be defined as the slope or gradient of a tangent line to a curve at a given point. Derivatives are represented as dy over dx, and the process of finding the derivative of a function is called differentiation. Here's the basic way to differentiate a function. In this method, we're using something that we call as the power rule, where the power of x gets subtracted by 1, while the entire function is multiplied by the value of the original power.
Let's say you work for a motorcycle company and recently you and your team have finished the prototype for their brand new motorcycle. Now you and your group of researchers are responsible for testing the product's performance and capabilities to see whether or not the product meets a company expectation and can be introduced to the market. There are a few things that you are required to report above. First, the speed at which the motorcycle moves, or in the other words, its velocity at a given time. Second, the motorcycle's acceleration at a given time. Third, the duration it takes for the motorcycle to reach a specific speed. So basically, we'll be using the derivative to find the velocity and acceleration. So how exactly do you use derivative to calculate velocity and acceleration? To find both velocity and acceleration, we first need to find the function that shows the object's displacement at a given time, or what we usually call the position function. To find the velocity at a given time, all we have to do is find the derivative of the position function, then substitute the value of time. The same thing goes for finding acceleration. But instead of finding the derivative of the position function, we need to find the derivative of the velocity function. So, in order to find the acceleration function, we have to find the derivative of the position function. Take for example, the displacement in meters of a motorcycle moving in a straight line is given by this equation as equal to 10t cubic plus 5t plus 10, where t is measured in seconds and we are to find out the velocity of the motorcycle at 5 seconds, the acceleration at 3 seconds, and the duration it takes for the motorcycle to reach 500 meters per second.
Firstly, we need to find the velocity function, which is given by the derivative of the displacement function. And to do this, we use the parallel x explained before to get the velocity function, and we should get this equation. Then, to find the velocity of the motorcycle at 5 seconds, we just have to insert the value and finally get the velocity of the motorcycle, which is 755 meters per second. Secondly, we need to find the acceleration function. To find the function, we have to find the derivative of the velocity function. To do this, we use the power rule once again, just like the first equation, and this should give us this equation. We insert the value once again and get 180 meters per second square. For the last question, it still talks about velocity, but instead of asking us to find the value of the velocity, it asks us for the time. You know that velocity is given by this equation. So to find time taken to reach 500 meters per second, we just make this equation equal to 500 meters per second. Move things around and we should get 4.06 seconds.
It's quite simple, isn't it? As you can see, finding out the speed and acceleration was made easy with the use of derivatives. While there are many other useful applications of derivatives, this is just one. Similarly, many different mathematical concepts can be applied to real-life scenarios, and figuring out where you can apply them will surely make your life much easier.